through 80 and working on slightly larger ionic compounds. So these ionic compounds are known as tertiary compounds, and for the most part, most of them will contain 3 or more different elemental symbols in those. And for us, the tertiary compounds means that we have a polyatomic ion present. So poly, means many. Atom, so many atoms. So these type of ions is not one single element carrying a charge, but it's a group of atoms that share a charge. The polyatomic ion functions as a single unit. It represents a single cation or anion. And we do not break them apart when we go between the name and the formula, or the formula back to the name. We keep that poly unit together. There are lots of different polyatomic ions, but the ones that we need to be able to use and recognize are listed on our reference table E. So here is a copy of table E. So a couple of things with table E. The first thing, the first column, okay, represents the polyion's symbol. So this is your poly symbol. And it shows you the elements, each of their subscripts, and a shared charge. The next column provides the name of the polyatomic ion. So the first thing that I want you to do in your notes or in your actual reference table is, I don't like this bracket. It becomes very, very confusing. I don't know why they designed it this way. But this is a polyatomic ion. This is the same polyatomic ion, just shown in a different way. So what I would like you to put there, cross out that bracket and write the word or. So for the acetate ion, we either use the symbol as shown here, or we will use the second symbol below it. They both represent acetate. The other thing that I want to point out to you is that there are polyatomic ions that have very similar names and formulas. So take a look here. We have chlorate, ClO3, but up above it we have chlorite, and it's still chlorine and oxygen, but ClO2. We have hypochlorite, chlorine and oxygen, different ratio, and we have perchlorate, still chlorine and oxygen, but a different ratio between the chlorine and the oxygen. And on the other side, we have sulfite, sulfate, hydrogen sulfate, so very similar names. So all I'm going to say is, be careful when you're choosing the polyatomic ion that you're matching the name or the correct symbol, because sometimes they start to look a lot alike and they start to sound alike. So take a look, a little bit of notation here also. So I'm going to look at oxalate. The symbol for oxalate is C2O4. So this is the symbol. So those 2 carbons and 4 oxygens make up the oxalate polyatomic ion. But the 2 minus, that is the shared charge. So the symbol for oxalate, C2O4, this is the shared charge. Now, if we take a look at something like thiocyanate, SCN, so like oxalate, the formula or symbol for the thiocyanate is SCN. Here you will just see this minus sign. So that's understood that the shared charge value is a -1. The magnitude is a -1. So make sure you understand the what represents the symbol, what the shared charge is, and you're paying attention to the names. So we're going to start working with these. So moving on to page 79. So let's start simple. Let's start with, we are given a chemical formula and we have to come up with the chemical name. So here are some clues so that you always get this right. If you notice 3 or more different element symbols in the formula, circle the polyion. Match each partner's symbol to the correct name. So use your table S. If it's a single element symbol, use table S. If it's a polyion because you circled it, use table E. Like the other formats, we have to just think about the second partner's ending. If the second partner, the anion, is an individual element, you have to change the ending to IDE. But if the second partner is a polyatomic ion, you don't need to do anything to the name. So just use the table E name. So let's look at a couple of examples here. So take a look. Our first example, we see the symbol Na, the symbol S, and the symbol O. So there are 3 different elemental symbols in this chemical formula. That means that there is a polyatomic ion. Now, the elements making up the polyatomic ion, they are grouped together. They can't be split apart. So your choices is, if there's a polyatomic, it's either Na2S or it is SO4. So when you go back to your table E, take a look. On your table E, you have down your list, you see an Na2S, so Na2S in either column. There is not. So then look at the other combination. Is there an SO4? Is there an SO4? Yes, I see. There's an SO4 right here. So on this particular example, what I would circle is the SO4 because that is what I see on table E. So that means for Na, I have to look at table S. And for what I circled, this is going to be on table E. So according to table S, Na stands for sodium. And according to table E, SO4 stands for sulfate. My second partner is a polyion, so I don't need to do anything to its name. So the name of this substance is sodium sulfate. Taking a look at the next example, okay, I see there's an N, an H, and a Cl. So there are 3 different elemental symbols. So that means there is a polyatomic ion. So either the polyatomic ion is NH4 or H4Cl. When you go back up to your table E and you look down the columns, do you see a symbol NH4 or do you see H4Cl? Well, right here is the NH4. So NH4 is the polyatomic ion. So what I circle, this is the polyatomic ion, and the Cl is by itself. So for this one, I need to find NH4's name on table E, and I need to find the second partner, because it's a single element, on table S. So when I look on table E, NH4 is known as ammonium. And according to table S, Cl stands for chlorine. Since chlorine is the element's name, I have to adjust the ending from "-ine" to "-ide". So my final substance name would be ammonium chloride. So last example here. In this last example, I see a W, a P, and an O. So there's 3 different elements, so that means that there's a polyatomic ion here. But when you take a look at this one, it's a little bit unique, and you should be able to pick out the polyatomic ion because it is already kind of circled for you. So for us, what we see in these set of parentheses is the polyatomic ion, where W is by itself. So W, we would find its name on table S, and what is in parentheses, we would find that on table E. So according to table S, W stands for tungsten. And when you go find PO4 on table E, it is known as phosphate. And because our second partner is a polyatomic ion, we don't have to do any name change, so the compound's name is simply tungsten phosphate.